Following on from the previous video, we've added our particle. Now we need to get our particle to move around accordingly. So let me just illustrate this. So this is a working example. So as you move the circle around, you can see keep an eye on the particle. As you move the circle about, the particle will move accordingly. Okay, hang on, that was a bit fast. So the particle will move like that. So that's our job to implement that. So hang on. So this is currently from the previous video. This was where we were at. So that's our black particle there. So we need to get it to rotate accordingly. So going back to here, right from the start, the particle would be right here. So by the time it gets to an angle of t, the particle would be somewhere around here. Let's just say this particle will move around like this. Will move around like this, and then it will probably end up somewhere here. The trick to doing this is to realize that for given time t, the arc length here will be exactly the same as this length here. So our job is really to find this angle here, because for given t, we need to find, let's call it beta. We need to find beta. For given t, the point is that for given t, the arc length, well, this arc length will be the same as this arc length. So if we can somehow find this angle here, then we can locate where the particle should be. So our next task is to work out this angle b. Beta, sorry. So we need to create a machine where you input the time, you input t, and then it will work out this arc length. It will work out the arc length. And then once we've got the arc length, we need to realize that we need to somehow work out, well, this arc length here will be the same as this arc length. So it's like me giving you this. I've got a circle here of radius b. I need to work out this angle beta here, and then I know this arc length because I've just worked it out here. So what we need to do is we need to create another machine where we input the arc length, we put it into the machine, so we know this arc length here, and then it will spit out the angle beta. That's our aim. We need to create a machine. For given t, we can work out the arc length. Because we know that this arc length is the same as this arc length, we can feed it into another machine, which will then work out the angle. Okay, so let's start again. So let's work out the arc length. So it's like me giving you this. This is radius a, and the angle is t. Therefore, we can work out this arc length. So to work out the arc length, let's work out the whole. Well, I'm expecting you to be able to do this. So it will be 2 pi a, cut it into 2 pi equal pieces, and then times the angle t, and then simplify this, it will then give you at. I'm expecting you to know this by now. This arc length is at. So for given angle, the arc length will be at. So now that we know that this length here, this arc length is at. So now looking at the smaller circle of radius b, so we are looking at this circle here. It has a radius of b. We need to work out the angle beta. We know the arc length is at. So now let's work out beta. So looking at this, let's work out the whole circumference of the small circle. That would be 2 pi b, cut up into 2 pi equal pieces, and then times beta. That should then give us the arc length. So these two will cancel each other out, giving you b times beta equals at. So divide both sides by b. So beta, the angle, is given by AT over b. So what this is saying is that this angle here, beta, is actually you getting the radius of the big circle times the current time or angle, and then divided by the radius of the small circle. That will then give us beta. So once we know beta, we can identify where our particle should be. I will implement it in the next video. Okay. The point here is that this angle here, as this circle moves around, the angle beta is given by this. Okay, I will implement it in the next video.